All right, testing C++, and we're in chapter 7, continuing on page 293 and 294. Using arrays to summarize survey results. Popular array uses include the summary of a number of responses to a survey. We want to write a program to manage the responses of a survey from students who filled out a cafeteria survey. On the top of page 294, 20 students were asked to rate on a scale of 1 to 5 the quality of the food in the student cafeteria, with 1 being awful and 5 being excellent. Place the 20 responses in an integer array and determine the frequency of each rating. So we wanted to know how many 1s were received, how many 2s received, how many 5s a rating of an excellent were received. Array responses is going to be initialized as a constant array to contain the 20 responses from the school cafeteria survey by students, where 1 represents awful and 5 represents excellent. So in line 10, we have a constant size array template named responses size, and the response size is going to be 20. So we're declaring the array size of responses. In line 11, we have a constant size t frequency size of 6 is initialized. So the size of the array frequency is going to be 6. In line 14, we initialize a constant array to 20. That would be subscript 0, 1, 2, 3 through subscript 19 to contain the actual survey responses from the students. And we're initializing the array responses using the braces to place in each compartment of this responses array the responses the students had indicated on the cafeteria survey, 1 being awful, 5 being excellent. So the only responses that we can have is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we're going to capture those 20 responses by those 20 students, and they responded with responses of 1 through 5. We don't want those responses to change. We're not going to multiply or divide those responses, so that's why we're declaring that responses to be a constant array. In lines 14 through 15, we talked about initializing responses to its starting values. We use responses to store the student responses from the survey. We use frequency as a 6-element array to count the number of occurrences of each response. So responses is the size of 6. That's subscript 0, subscript 1, 2, 3, 4, 5 for 6 elements, 0 through 5. That would be a size of 6. And in line 18, we are initializing our array frequency with an unsigned int. We know its frequency size is 6. We're going to initialize each of those compartment values to 0. So now we have our responses array. And we've initialized it to the responses from the students. Only values 1 through 5 were captured as responses from the survey. we have compartments 0 through 19. So we have responses sub 0, responses sub 1, responses sub 10, responses sub 15, responses sub 19. We also declared frequency to have a size of 6, so that's frequency sub 0, frequency sub 1, frequency sub 4, frequency sub 5, for 1, 2, 3, 4, 5, 6 compartments, remembering that all arrays start with subscript 0, so we're off by 1 scenario. And then line 18, we said initializes frequency to 0. So frequency now frequency sub 0 through frequency sub 5 has been initialized to 0. Each element of the frequency array is going to be used as a counter for one of the responses. Frequency is initialized to 0 in line 18. For clarity purposes, we ignore frequency sub 0. It makes more sense that our responses are frequency sub 1. How many responses did we get? We want frequency sub 1 to be a counter for the number of ones that were responded. We want frequency sub 2 to be controlling a counter value for the number of 2 responses that return. Frequency sub 3 is going to keep and maintain a counter value for the number of 3 that were responses, and so on. So frequency as an array is maintaining the count of the frequency, that is the number of times that the subscript occurred, 1, which is response 1. The subscript 2 indicates the frequency of a survey response of 2, and frequency sub 3 represents the frequency of a 3 response, and so on. So in lines 22 and 23, we have our for iteration. For each answer, while answer is less than responses.size, which is 5, select response element and use that value as a subscript for the frequency to indicate the value by 1 frequency. Frequency array is maintaining the count of the frequency of the responses of 1 through 5 by observing the frequency subscript. So for size P, answer is set equal to 0. When answer is less than responses.size, which is 5, we're going to execute the body of the loop. So we're going to increment frequency. So it's our frequency array that we're going to be modifying. The frequency subscript is responses sub answer. Well, answer is 0, and responses sub 0 is 1. So we have a rating of awful for the school cafeteria. 1 is returned, so responses sub 0 is 1. And we're going to increment frequency sub 1 from 0 to 1. And we're at the bottom of the loop, so we return to the top, and answer is incremented from 0 to 1. Keep track of that somewhere. Answer is less than responses.size of 5, so I'm going to execute the loop, and I'm going to increment frequency, but frequency subscript is responses sub answer, and answer is now 1, and the responses sub 1 value is 2. So frequency sub 2 is going to be incremented by 1, and so it's going to be 1. We're at the end of the loop, so I'm going to go back to the top, and answer is incremented to 2. It is less than 5. I'm going to execute the body of the loop and increment frequency sub responses sub 2. And responses sub 2 has a response value of 5. So I'm going to increment as a counter frequency sub 5. There was a 5 response, so I'm going to increment the count 1. And return to the top of the loop. Answer increments to 3. It is less than 5, so I'm going to increment or execute the body of the loop and increment frequency sub responses sub answer. Answer is 3, so responses sub 3 is 4. Responses sub 3 has 4 for a value. So we're going to increment frequency sub 4 by 1, so it goes to 1. Go to the top of the loop and answer increments to 4. It is less than 5. So I'm going to execute the body of the loop and increment frequency responses sub answer 4. Responses sub 4 is equal to 3. So I'm going to increment frequency sub 3. We have a response of 3. Count that once. And return to the top of the loop. Answer increments to 5. While answer is less than, responses has a size of 20. I'm sorry, that should be a 20. Responses has a size of 20. 5 is less than responses dot size. I'm going to execute the body of the loop and increment frequency again, keeping count of the responses. And responses sub 5 is 5. So I'm going to increment frequency sub 5. Frequency sub 5 was 1. It's now 2. So far, I have 2 responses for 5. 2 responses for 5, 1 response for 1, 1 response for 2, 1 response for 4, and then again 2 responses for 5, and so on. We're going to print our headings, and then we're going to increment through the array frequency to output the frequency of the response rating and that frequency amount. So let's execute. So here is figure 7_09. I'm going to execute, and I have my title, rating, and the frequency. So the rating, the response was won by a student in the survey, and the frequency, the number of times that a rating of 1 occurred, is 3. Rating 2, the number of times that a rating response of 2 occurred, is 5 times. Rating response of 3 occurred 7 times. Rating response of 4 occurred twice, and rating response of 5 occurred 3 times. Again, this is a shared student data file, so you can create your project and run and execute the program, again, testing lines of code and maybe changing some lines of code. Now, we do have a warning when we're working with arrays. When looping through an array, the subscript should never go below 0 and should always be less than the total number of elements in the array. Remember, we are off by 1. 0 through 19 would give us a size of 20. 0 through 6 gives us a size of 7. So be sure to count 0. We can always be off by 1. Referring to a subscript outside the array bounds, that is less than 0, and it has to remain less than the array size, is referring to an array out of bounds. And this is an execution time logical error. It's you and my responsibility. So it's our logical error if that occurs. It's not a system error. So be sure you're checking to make sure that you do not cause an array out of bounds processing. Well, then we look at the range-based for statement on page 298. The range-based for statement allows us to manipulate all the elements in an array without using a counter, thus avoiding the possibility of stepping outside the array bounds and eliminating the need for you and me to implement some type of array bounds checking. So we have this automated range-based for statement that will iterate through an array beginning with subscript 0 through its maximum size. A range-based for statement's header contains a range variable declaration to the left of the colon and the name of the container to the right of the colon. Now, sometimes the word container refers to our data structure. So in our case, we'd have an array in the container's position. You can use a range-based for statement to modify each element of the array by making the range variable a reference. Remember with the ampersand? The range-based for statement can be used in place of a counter-controlled for statement whenever code looping through an array does not require access to the elements of the subscript. Our next program, figure 07_11, implements a common process when we work with arrays, and that is to process all elements of an array. The range-based for statement allows you to process all elements of an array without using a counter, thus eliminating the possibility of stepping outside the bounds of an array. And that would be a logical error, not a system error, and one that we must avoid. For each iteration, we're going to assign the next element of the array to an integer variable called the range variable, and then we continue the body of the loop. So in our next program, we're going to look at particularly line 9, or line 12 on the top of page 299. And there we see the code for a range-based for statement. For this is our range variable, and it's a variable name declared to be a type, and we have the colon, and following the colon is the container we're referencing, and a container is another name for a data structure, and the data structure we're using in this program is an array, and we have already declared the array items in previous code. So as we iterate through, we're going to assign the next element of the items array to the local range variable item, and we're going to print it out. We're at the end of the loop. Again, returning to the top of the loop, we continue to iterate through the next value in the container items array and assign it item, and then we're asked to output that value. So this is a mechanism to step through every element of an array from items sub-zero through its last value and printing each item out without using a counter-controlled variable. And the range-based for statement knows the size of your container, so it will not exceed the bounds of your array. So items before modifications, the items were assigned and initialized 1, 2, 3, 4, 5 in our items array, so we're going to output those results. Line 16, we multiply the elements of items by 2. Now, if you wish to change or modify the values in an array, you can use a range-based statement to modify array value contents. The range variable's declaration changes a little bit, and it indicates that item ref, the variable name, in the range variable item ref is a reference, and we're going to be making use of your item in our range. We're going to multiply every item in array items as we iterate through the loop, looking at the first subscript value, the second subscript value, the third subscript value, and so on, multiplying each and assigning that by 2. So we had items initialized to 1, 2, 3, 4, 5. And now in line 17, and we output that value before modification. Now we're going to iterate through with the base range-based for statement. We're iterating through the items array container. Item ref is a reference. It's a local variable, and it's referencing an integer in the items list. So right now it's referencing the subscript items sub-zero. And I'm going to multiply item ref 1 times 2, which would be 2, and assign it to the integer that item ref is referencing, which is item sub-zero. I iterate through the loop, going to the next subscript. Item ref is an integer reference to the next item in the container, which is item 1. Int ref is going to be assigned itself times 2. 2 times 2 is 4. Item ref is a reference to it, so it's reassigning item sub-zero. I'm iterating through this array using my 4 base range-based for statement. So iterating to the next, item ref is a reference to the next element in items, which is item sub 2. It is 3. Item ref is 3 times 2 is 6, and it reassigns what it's referencing, which is the value stored in item sub 2. I go back to the top. The range-based for statement allows me to look at the next available element in the array container. Item ref is referencing an integer, which is 4. I'm going to assign item ref 4 times 2 would be 8, which reassigns item sub 2. Go to the top, and I'm looking at the next item sub 4. Item reference is referencing an integer located at item sub 4, which is 5. Item ref is multiplied by 2, so 5 times 2 is 10. Item sub 4 is assigned. I go back to the top, and the range-based for statement knows that I'm iterated through all of the elements of the item container and will stop executing. And I'm able to continue to display the items after modification. Again, I'm just going to simply iterate through using the range-based for statement and print out the current value of each item in items of 0, items of 1, items of 2, items of 3, and items of 4, which prints out 2, 4, 6, 10. So let's make sure that that occurs when we execute the next program. Figure 7_11, we're referencing the mechanism of using the range-based for statement, avoiding needing to print to calculate a control variable within our for iteration, and avoiding processing an out-of-bounds array logical error. Let's execute. Items before modification, well, we initialized our array to 1, 2, 3, 4, 5. And items after modification, we used an range variable reference to an integer as we step through the contents of the items array, subscript 0 through its last subscript, multiplying each item reference, which is item sub 1 value times 2, item sub 0 value times 2, item sub 4 value times 2, and then we print by iterating through, again using a range-based for, and output the new values assigned to our array, 2, 4, 6, 8, 10. All right, as always, be sure to return to E2L. Where all details are now listed in your unit number 7 lesson plan for homework, projects, and tests. All right, thank you very much.